Well, now that we've looked at how to write down the correct number of significant figures in a measurement, we want to look at how do we write down the correct number of significant figures when we do a calculation. And this is not entirely intuitive, but it's not too terribly difficult as long as you keep in mind that there is more than one rule that applies here. There are actually 3 rules. I'm going to teach you 2 of them now and save 1 of them for next semester. The first rule is for addition and subtraction. The second rule is for multiplication and division. And the third rule is for exponents and logarithms. Well, let's do the addition and subtraction rule first. So, when we're doing an addition and subtraction problem, then the answer needs to have the same number of decimal places as the measurement with the fewest decimal places. And the best way to describe this is just to show you a problem. So here we've got 3 numbers, just 3 numbers that we want to add together. Presumably somebody made these measurements. And of course, we can just plug that into our calculator, and the calculator will do a great job of adding those numbers together. However, we need to get the correct number of significant figures when we write this answer. Well, when we look at this, you'll see that we've got I've highlighted in red the last significant figure in each of these numbers. And when we look at what place those red numbers are, that's going to be in the hundredths place for this one. That 2 is in the hundredths place. This 2 in the 1.322, that's in the thousandths place. And then this one is in the tenths place. Now, one thing I want you to keep in mind is that a decimal place doesn't necessarily have to be to the right of a decimal. It can be to the left of the decimal. So, I mean, we've got here the ones place and the tens place. I'll show you an example using those here in just a few minutes. But we want to round this to the biggest of these places. In other words, the one that is the least to the right. So when we compare the hundredths, the thousandths, and the tenths is the biggest of those. Therefore, it's the least to the right. And we need to round our answer to the tenths place. So our answer here is going to be rounded to the tenths place where that 8 is, and it'll be 104.8. And so that's how we do addition and subtraction. Let's look at a couple of more examples for addition and subtraction. Some practice problems. So here we've got 2.11 plus 21.5. Of course, the calculator can add these together. You hardly even need a calculator for this. But we want to look at where the last significant figure is in these numbers. Well, the last sig fig in the 2.11 is in the hundredths place. The last sig fig in this one is in the tenths place. The one of those that is the least to the right is going to be the tenths. So we're going to round this to the tenths place, that's 6. So the answer will be 23.6. And that's simply how we do it. Now, if it's one of those problems, that's pretty easy. But let's do a couple of more here. So 10.0 minus 6.123. Well, the last sig fig here is in the tenths place. The last sig fig here is in the thousandths place. The one of those that is the least to the right is the tenths place. So when we have our calculator answer of 3.877, we're going to need to round that to the tenths place. So this will become 3.9. All right. So next, this one, this is one that usually drives people a little bit batty, and it has to do with that our decimal place doesn't necessarily have to be to the right of a decimal, and in fact, it doesn't even have to have a decimal in the number for this rule to apply. So here, when we write 10 plus 11 plus 12, we of course are going to get 33 in our calculator, but we want to look at what is the last significant figure in each of these quantities. Here, the last sig fig is in the tens place, this one is in the ones place, and this one is also in the ones place. Well, given the way these numbers are written, since that is in the tens place, we need to round this answer to the tens place. So we need to round that to 30. And that's enough for some people just to turn off the video and give up on chemistry and go change your major to something else. And I'm going to encourage you not to do that. I want you to stick around, and I think you can get this. It's not too bad. Just stick with it, and you're going to get this down. Let's do some more here. All right, on this one, 9.01 liters, and then this is 6.01 milliliters. Since we have different units, and I did this on purpose, since we had different units, that means that we need to convert one of these to the other before we add them together. Well, I'm going to convert them both to liters for purposes of making this clear. So here, let's go over, I've rewritten these numbers as liters here. And so when we add them together, so 9.01 liters and then 0.00601 liters for the 6.01 milliliters, then when we add those together, 6, and then 1, 0, and 9, so 9.01601 liters. And so that is our answer. All right, so we go back over here, we'll get 9.01601. Now I'm going to go back over here to our page where I've written this out. So 9.01601. Our last sig fig here in the 9.01 is in the hundredths place. Our last sig fig here, this one is in the, I'll have to figure this out. So tenths, hundredths, thousandths, 10 thousandths, 100 thousandths place. So hundredths place versus 100 thousandths place. We're going to round to the hundredths place. And so that will become 9.02. So go back over here, and we'll put 9.02. So it takes a little bit of work and a little bit of practice to get good at this, but you can get good at it. All right, this one's pretty straightforward. I wanted to make sure that we were doing some subtraction here. So 1.08 minus 0.585. The calculator answer is here, 0.495. Our last sig fig here is in the hundredths place. Our last sig fig here is in the thousandths place. So we're going to round this to the hundredths place. When we round that to the hundredths place, of course, that 9 has to round up. And so this will become 0.4, not 49, but it will become 0.50. And so we don't want to, when it rounds up and becomes a 0, we don't want to forget to put that number because we determined that the hundredths place was significant. Let's look at another one here. This one's pretty easy. So we add these two numbers together. There's our calculator answer. The last sig fig here is in the hundredths place. The last sig fig here is in the tenths place. So we're going to round this to the tenths place. So this will become 30.2 grams. Next, all right, this is another one that sometimes will drive people a little bit batty. So 1,010 square meters and 5.000 square meters. Of course, 1,010 plus 5 is 1,015. Our last sig fig in this number is in the tens place. Our last sig fig for this number is over here in the thousandths place. So we're going to need to round this to the tens place. So when we round that to the tens place, this will round up, and that will become 1,020 square meters. Next, all right, 1.3 times 10 to the 3 and 1.2 times 10 to the 2. Now, I do this one as almost as a cautionary tale, and I'm going to go back over to our page where where we write these things out. So 1.3 times 10 to the 3, that's 1,300, and 1.3 times 10 to the 2, that's 130. And so when we come back over here, we get 1,300 and 130, and I'm not concerned about the units because I didn't write any units on this. But of course, when we add those together, we'll get 0, 3, 4, and then 1. So 1430 is going to be our number there. Well, now let's go back and look. Our last significant figure, and that 1.3 times 10 to the third, is in the hundreds place, and the last sig fig here is in the tens place. So the one of those that is the least to the right is the hundreds place. So we're going to round that to 1400. Now, of course, we can rewrite 1400 if we want to put this back in scientific notation as 1.4 times 10 to the 3. And so now when we go back, we'll get 1.4 times 10 to the 3. Okay, we've got another one here. All right, so we've got 1,000 plus 1. Of course, that's 1,001. You don't need a calculator for that. But when we look here, our last significant figure in this 1,000 is in the thousands place. Our last significant figure here is in the ones place. So we need to round this to the one that is the least to the right, and that is going to be the thousands place. So this will simply become 1,000. What this means is that we didn't know this 1,000 meters well enough when we added 1 meter to it that would affect what the number is. And so really the best we can say about this measurement is that it's still about 1,000 meters. If we wanted that 0 to be significant, if we had written down this number and we had wanted that 0 in the ones place to be significant, we simply could have put a decimal point immediately after that third 0. All right, I've got one more, and this one is similar to the one that we had that was 2 above. I'm going to write this number down. So 1,300, okay, and then 4.3 times 10 to the 2, that is 430. And this is a subtraction problem, and so when we do our calculation, we'll get 0. We'll see, borrow there. This became a 2, and that will be 8. So 870. So 870 is our answer. Now, before we put what our final answer is, we need to go back and look at what place has the last sig fig. Well, here the 3, that 3 is in the hundreds place, and it's the last sig fig, and this 3 is in the tens place, and it's the last sig fig there. So when we add those together, we're going to need to round to the hundreds place. And so when we round to the hundreds place, this is simply going to become 900. And of course, we can write that in scientific notation as 9 times 10 to the 2. So when we come back over here, we'll get 9 times 10 to the 2. All right. So practice will make this go much easier. So I told you there were 3 rules. The first rule is addition, subtraction. The second rule is multiplication, division. And as I mentioned, that third rule we're going to save for a later time in your lives. But we want to look at multiplication and division. So multiplication and division. It turns out that the rule for multiplication and division is easier than the rule for addition and subtraction. It is. So the rule for multiplication and division is easier than the one for addition and subtraction. So the final answer in a multiplication or division calculation has the same number of significant figures as the measurement with the fewest significant figures. So here is an example. We've got 2 numbers that we want to multiply together. These are presumably some measurements that we have taken somewhere. 1.3 times 1.1, and our calculator answer for this comes out to 1.43. So 1.43. But we need to look at how many sig figs are in each of those measurements. The first one at 1.3 that has two significant figures, and then the second number also has two significant figures. And what that means is that we need to round our answer to the smallest of those two numbers. Now, since they're both 2, that means we're going to round our answer to have two significant figures. So our final answer here is going to come out to 1.4. Now, some students find this a very difficult thing to do because it feels like you're throwing away perfectly good numbers. And so you're like, what about that 3? Is that 3 not important? Well, no, it isn't. That 3 ends up not being significant. So let's do a couple of practice calculations, and then we're going to go to the in-class assignment and practice doing these. So here is our first one, 210 times 215. Well, when we multiply those out, the calculator quite easily will multiply that out to give us 45,150. When we look, our first number here, 210, has two significant figures. That 0 is not significant because there is no decimal point present. Now, if we had put a decimal point there, that would indicate that we have 3 sig figs instead of just 2. So we have 2 significant figures there, and we've got 3 significant figures on this number. Well, the smaller of these two numbers is 2, so our answer needs to have 2 significant figures. So we'll just count off 1, 2. We're going to round to that 5. So the answer is going to become 45,000. So 45,000. And that is how we do that calculation. Let's do another one. All right, this is another one that drives people batty, but 1 times 6.123, no need whatsoever here to have a calculator. That's going to be 6.123. But what it does take is it takes a little bit of thinking about this to make sure you understand. We look at how many significant figures this has. Well, this has 1 significant figure. This has 4 significant figures. The smaller of those two numbers is 1, so our answer must have 1 significant figure. So our answer is only going to be 6. So we'll end up with 6 grams. Now, if we had wanted to have more sig figs in this answer, which we presumably could have, if we had wanted to have more sig figs, then we would have needed to have more sig figs in our measurement here. And that's really the lesson is you can't add significant figures after the measurement. You have to do it while you're doing the measurement. So next, let's look at this one. You'll notice I put the decimal point there, but 10 times 11 times 12 comes out to 1,320. If we look, this has 2 significant figures, 2 significant figures, 2 significant figures. The reason this one has 2 sig figs is because there is a decimal point present. Remember, rule 4 for our sig figs was numbers on the right of non-zero numbers are significant if there is a decimal point present. And so since that decimal point is present, that 0 on the right is significant. Well, our answer needs to have 2 significant figures, and so this answer is going to become 1,300. And that will be our final answer. Well, we're now going to go look at problems number 41 and 42 on the in-class assignment. So let me switch over here. All right. So on this, I've got a couple of different calculations. I've got an addition, a subtraction, a multiplication, and a division problem. And go ahead and get our calculator on the screen. And I turned on an additional light there to give us a little bit more light on that calculator. All right. So for this one, I think it's easiest if we just rewrite it. Now, we don't necessarily have to rewrite this, but I'm going to go ahead and rewrite it. 12.0550 and then 9.05. And when we add those together, so 12.0550 plus 9.05, and we get 21.1050. Now, to get the correct number of significant figures, we need to look at where our last sig fig is. Here, our last sig fig is in the 10,000ths place. This 5 is in the hundredths place. Therefore, we're going to round it to the hundredths place. And our answer is going to be 21.11. So 21.11 will be our correct answer there. All right, in a similar fashion, let's come over here. This one is subtraction, but I am going to rewrite it. So 257.2 minus 19.789. And again, we're going to let the calculator do the work. So 2 minus 19.8. All right, and we get 237.411. So now that we've done that, we look, our last significant figure here is in the tenths place. Last significant figure here is in the thousandths place. We're going to round that to the tenths place. So 237.4 is our number there, our final answer. On this next one, since it's just multiplication and we've already got it written out as multiplication, we're just going to write what the answer is right next to it. So clear that. We'll do 6.21 times 10 to the third times 0.1050. And the nice thing about this calculator is you don't have to have the parentheses around. So I'm going to hit enter. And so our answer, our calculator answer is 652.05. Now, our rule for multiplication and division, it's the number of significant figures. Here we have 3 sig figs. Here we have 4 sig figs. So our answer is going to have 3 sig figs. So we're going to round that to 652. All right. So now let's do the same thing on this one, except you'll see that it is division. So 0.0577 divided by 0.753. Now this is going to give you a big long answer, and I'm just going to write it out completely like this. So 0.076626826. All right, and you'll see here that we've got lots of numbers, way more numbers than we need. When we look, this number has 3 significant figures, and this number also has 3 significant figures. Since they both have 3 significant figures, we're going to round this so that our answer has 3 significant figures. And so that's going to give us 0.0766. So our 6 here would be our third significant figure, and since that number is less than 5, we'll round it to 0.0766. If we wanted to, we could also put that into scientific notation, so 7.66 times 10 to the negative 2. And that might be something that you would be interested in doing in certain situations. Okay, well, now that we've done the bunny slopes here, we're going to step it up and go to the slightly more challenging kind of problems here. So we're stepping up to not quite the black diamond slopes, but it's going to be a higher level here when we do number 42. All right, so let's go ahead and let's just go through each of these. For this, we do need we do need to write out our order of operation. And many of you have learned this before, so please excuse my dear Aunt Sally. And I purposely have done this for multiplication and division. We'll do those together, going from left to right, and then addition, subtraction, we'll do those together, going from left to right. So parentheses, exponents, multiplication, division, addition, subtraction. And that is our order of operation. And some people learn this as BEDMOS. It gives you the same answer as long as you group the multiplication, division, addition, subtraction together. So what we're going to do is that we're going to go ahead and just do this calculation. I'm going to do it one step at a time, and we're not going to pay attention to significant figures to start with. So here we've got subtraction and a division. Well, we're going to do the division first. So we'll write 320.55 minus whatever that number comes out to. So I'm going to do 6104.5 divided by 2.3. And that number comes out to this big long number. I'm not going to write all of them. So 2654.13. Remember, we're only going to have two sig figs there, but I'm just going to go ahead and write that out. And then we'll do 320.55 minus 2654.13. And you'll see the number that we get there is negative 2333.58. All right. And if we had not retyped this in, we would have gotten a slightly different answer. But the point is that that number has too many significant figures. What we want to do is we want to apply the rule for each step. And for our first step, the rule is for division, it's the number of significant figures. Well, this number has 5 significant figures, whereas this number has 2 significant figures. Well, 5 and 2, the smaller number is 2, so we're going to count 2, 6. That 6 is our last significant figure. Now, there's this little trick I like to do where I just put a little dot to indicate what the last significant figure is in that number, because if we were going to round at that point, we would call it 2700, but we're not rounding because we still hadn't finished the problem. The last sig fig here was that 5, so I'll go ahead and put the dot there. And now that we're doing subtraction, the rule for subtraction was the place. Well, here we've got the hundredths place versus the hundreds place. That means that we'll need to round to the hundreds place. That one is the least to the right. So that means that our final answer is going to be negative 2300. So negative 2300 will be our final answer. All right, if you had decided to round at this point and call this negative 2700 and then do the next step, you would have gotten a slightly different answer. You would have gotten negative 2400. I recommend just doing the calculation and then rounding at the end, but you'll need to keep track of where that last sig fig is for each part of the operation. All right, so here we've got another problem. We've got 285.3 times 10 to the 5th. That's really not even in proper scientific notation. I'm going to write that in regular notation. So 285.3 times 10 to the 5th is 28530000. And then 1.200 times 10 to the 3rd, that is simply 1200. And I'll go ahead and put a decimal point there because all 4 of those are significant. And then I'll go ahead and rewrite this, 2.8954. All right. So now that we've done that, we'll go ahead and do this subtraction. Make sure that is on camera. It is. All right. So 2853000 minus 1200. And you'll see the number that we get there is 28528800 times 2.8954. And so now we're just going to multiply that by 2.8954. And that will give us this number, which I will go ahead and write out. So 826.02287.52. All right, way too many sig figs. You never want to write this down as your final answer. It is okay when you're doing a calculation to write down more than you need and then round, but you don't want to like take this and carry it on and use it for some other, like you certainly wouldn't want to like put that in a paper or something, or in a, in your lab report. Okay. So now that we've done that, we need to figure out where we round at each step. Well, here, our first calculation that we did, our first operation that we did was subtraction, and the rule for subtraction is the place. And so here, our last sig fig is that 3, which is in the 10,000s place, and the last sig fig here is in the ones place, and we're not so concerned about this one, but it's out there. But really, since that's subtraction, the 10,000s place and the ones place, we need to round to the 10,000s place. So ones, tens, hundreds, thousands, 10,000s. That 2 is going to be our last significant figure. Well, now when we multiply that out, multiplication, the rule is the number of sig figs. Well, over here, that number on the right, the 2.8954, of course, it has 5 significant figures, but this one only has 4, 2852. So it only has 4 significant figures. That means our answer should only have 4 significant figures. So 8260, that 0 is going to be our last significant figure. And we'll probably want to write this in scientific notation because there's not a good way to write it otherwise. So I'm going to put 8.260, that gives us all 4 of those sig figs, and then times 10 to the, so 1, 2, 3, 4, 5, 6, 7. So times 10 to the 7. All right, if you're getting confused, don't worry. Go back and go over this again and do some of the problems in the book, and I think things will work out nicely for you. Okay, so now let's do this calculation. 0.0045 times 20,000 plus 2813 times 12. Well, we're going to do multiplication first. So I'll do this multiplication and I'll do this multiplication, and I'll just go ahead and put those in there. So 0.0045 times 20,000. All right, and that gives us 90. And then here we have 2813 times 12, and that gives us 33,756. And I see that I have made an error in writing this down. All right, so I just need to fix that, turn that into plus. All right, so now we're going to take that number, so the 33,756, and we're going to add 90 to that, and we will get 33,846. So 33,846. And now we just need to look at what is the last sig fig in each of these numbers. Well, the first one, this had 2 sig figs. This had 1, 2, 3, 4, 5, 6 sig figs. So here we've got 2 sig figs. That 0 should be the last sig fig. Here, this one had 4 and 2. So this should have 2 significant figures there. And so that means that 3 in the thousands place. Now we're doing addition, so it's not the number of sig figs, it's the place. The last place here is the ones place. The last place there is in the thousands place. So we're going to round this to the thousands place, and our final answer is going to be 34,000. So 34,000. All right, let's do the next one. So here we've got parentheses, so we'll do the parentheses. Within the parentheses, we have a nested operation. So we're going to do the multiplication first. So I'll go ahead and write 863 times 1255 minus, and then we'll write down the value of that. So we'll do 3.45 times 108. And that gives us 372.6. All right, now let's do that operation, the subtraction inside the parentheses. So 1255 minus 372.6, and that gives us 882. So 863 times 882.4. Didn't need the parentheses there, but I wrote them anyway. All right, and now we'll just multiply those two numbers. So times 863, and that gives us 7611511. Oh, well, apparently this is, there we go. So 1511.2. And all right, so that is our calculator answer for this, but we're not quite done. We need to check out the number of sig figs. So we'll look at this first operation. This had 3, that had 3. Since it's multiplication, it's the number of sig figs, so 372. So that's our last sig fig there. And now we'll do the subtraction. Well, our last sig fig here is in the ones place. Our last sig fig there is in the ones place. That means this should be rounded to the ones place. Our next operation is multiplication. With multiplication, it is the number of significant figures. So here we have 3 significant figures. There we have 3. So 3 and 3 means that we should have 3 significant figures. So we should round this to 762 or 762,000. Or if we want, we could put that as 7.62 times 10 to the 5th. And that would also be the correct answer. Okay, well, that is a challenging concept. So we're at 37 minutes. This is shorter than I usually make a video, but I'm going to stop here. And then we're going to do the dimensional analysis all on that last video for chapter 1.